Okay, so let's talk about low-level design. Some of the things that we need to understand are those listed on the screen. So why do we need a detailed or a low-level design? So let's start working through that. The reason that we need a low-level design is that it explains in detail how the solution will actually operate. Also, it uses the high-level design, which we explained in previous sections, as a framework and what I mean by that is we can take several parts of the high-level design and put it in pretty much at the start of the low-level design document to start it off and give us a guide on how we actually write the low-level design. And it provides the information for the actual build of the solution to happen. So we're talking about things like management IP addressing and routing protocol selection, configuration, things like that, where we need to pre-build the solution in a lab before we actually roll it out to a customer network. So who will use a low-level design document? It's written by a network engineer or a technical design authority, and that is then used by them for the project implementation. For large projects, a low-level design might actually have multiple contributors, but a single owner. And what I mean by that is you might have a TDA or a technical design authority who owns the overall document, but you might also have certain parts of the document that are written by different people. So for example, you might have a load balancing expert writing a DNS load balancer or a server load balancer configuration section or design section, detailed design section, and that might be determined based on some lab testing that they perform. Or if you have a very specific requirement on the security in the SSL VPN, then a firewall expert or a VPN expert might write that part of the section. But the overall ownership is normally by the technical design authority or lead network engineer. So who else will use it? The Network Operations Center might use the LLD for operational support and troubleshooting after the project is implemented. So what normally happens is network architect hands over the HLD to the TDA, and the TDA hands over the LLD to operations. That says ops. And the operations team use that as a troubleshooting document, so they should be able to go to the document, find the section that they need to troubleshoot. So that might be the routing protocol or the SSL VPN, for example, and then they troubleshoot the network based on that document. So in summary, technical design authorities and network engineers. So the reasons why we should write a low-level design document, even if somebody insists that it's not required, we need to understand how the solution operates. So that includes physical and logical connectivity and what connects to what and how it actually fits together, which is mentioned here. So physical and logical connectivity and protocol configuration. We also need it for troubleshooting documentation and a structured implementation approach. So we're not just like moving into a lab environment and making up the configuration as we go along. We document it in a low-level design and we follow that process in order to bring it to life, as it were. The low-level design should be readable. I've read many over the years which are actually difficult to read and difficult to digest. So you want to make sure that it has good grammar, the diagrams are laid out well, and that it's easy to read even if you've not been involved in the project. So for example, that network operations engineer is your documentation readable at 3 AM in the morning? then you need to think about that. If somebody else reads this who's not been involved in the project, will they be able to understand it and digest it? So then we move on to what will the low-level design actually consist of. The low-level design consists of layer 1, which is physical, layer 2, which is things like VLANs, port channels and stuff like that, and then layer 3, which is IP addressing, routing protocols, redistribution and things like that. We'll also talk about the equipment which is used, including the physical and logical design choices. So that would be things like, for example, if you had a router with 2 line cards, how would you actually make that solution redundant and have no single points of failure based on a hardware perspective? But it might also talk about the redundancy and the failover from a WAN link perspective or an uplink perspective, for example. We talk about services being things like load balancers, security services like SSL and IPsec VPN. We also talk about, in the low-level design, routing protocols, interconnects between the old and the new network, and then the migration methodologies or processes, which we talk about a little bit later in the course. The low-level design normally gets to about 70 to 80% complete, and that enables us to build the solution to the extent where we can pre-stage and test it, or perform some pilot configuration and testing scenarios. After we're happy with that, we can then move into full rollout, and the reason that it gets complete 70 to 80% is to allow us to deploy the solution as we think it's going to be deployed, but gives us some headroom for changes to happen. So the 20 to 30% that still needs to be completed, that will be completed as we move through the pre-build process and perform various different tests and things like that. So let's talk about the 3 stages that are normally associated with the low-level design. Normally we get it to 70 to 80% complete, and that allows us to commence the build. We update the remaining 20 to 30% as the solution is deployed, so whether that's in the lab or at the customer site prior to cutting the solution over and making it live on the network. And then once it's complete, we hand it over to support as a support document. The low-level design, similar to the high-level design, is split into what I regard as 3 main sections. So there's setting the scene, which is highlighted in green on the screen already. And this involves various different parts that are probably already been covered to some extent in the high-level design. So we're talking about things like introduction and overview, an executive summary, so if a business stakeholder reads it, then they can understand what the solution is all about. Customer requirements, existing network architecture, proposed network architecture design, bill of materials, equipment specification, customer application flows, which should have been covered in the high-level design, or applications I should say, plus the customer traffic flows. So that's understanding whether the traffic is going to the data center in a co-location, whether it's a public cloud service, whether it's which public cloud service, so whether it's going to Amazon Web Services, Google, or Microsoft Azure, for example, or there might be software as a service or SaaS solutions And all of these things need to be taken into consideration, but they're normally covered already to some extent anyway in the high level design. So in the next part, in the middle part, the detailed core infrastructure, this is where we start talking about the specifics of the solution. So how do we represent layer 1, and layer 1 being physical connectivity? How do we represent layer 2, being VLANs and port channels, for example? Also, that might include spanning tree, if that's applicable to the design. When we talk about representing layer 3, there's multiple subsections that we need to talk about here. The IP addressing scheme, the subnets in use, routing protocols, if there's any public IPs in use, and finally, or probably not finally, there's probably some other things in the layer 3 section of this, but finally, if there is public IPs being used, then we need to consider network address translation and where that occurs on the network. So it could happen on a firewall or it could happen on a router, depending on the topology of the network. So when we talk about services and migration, what do we actually mean? Security services might be firewall, IPS, server load balancer, or VPN. We've then also got to consider services which are hosted in public cloud environments, management platforms, but in detail, as opposed to the high level design where we might just mention what management platforms are anticipated to be used. In the low level design, what we talk about with management platforms is how they're actually configured and how they communicate with the network devices that are being deployed as part of the solution. The migration section in the low level design really is going to cover at a low level how we are going to migrate from the existing network to the new network. And this will be a more detailed plan than in the high level design. And in the operational support side of things, on the low level design document is going to be what is the operational process. So if you have, or it might refer to an operational support process. So if you have, for example, a managed LAN and a managed WAN, then the low level design document should have all of the details and information around how you raise a support ticket, what contact details you need to use in order to get in touch with the managed service provider, SLAs and various other things like that in order to raise a support ticket. On this screen we look at various different things, but the main thing to call out is what physical interfaces are connected to what. So if you look at the MPLS CE2 router 01, you notice that the WAN interface here, which goes southbound towards the MPLS PE number 1, is connected to 10 gig 0/0/1. On that same router, another interface is connected to a router to the left hand side on 10 gig 010. So what this signifies is the exact physical interfaces that are connected. They're 10 gigabit Ethernet ports, and one is in chassis 0, slot 0, port 1. The other one is in chassis 0, slot 1, port 0. So what we're doing here is providing hardware redundancy, but we're documenting that in the low level design document. Here, what we're talking about is 10 gig 000 is used for one of the interfaces, but if you look at the rest of the MPLS handover, they're all gigabit Ethernet. So we have 5 handover interfaces in total, but we have one going from 10 gig 000, and then we have 4 separate handoffs from the MPLS CE-R01 and MPLS CE-R02 or CE2-R02 routers from their gigabit Ethernet interfaces. And this diagram could probably be updated just to indicate which one or which interface is 10 gig and which interface is 1 gig. So this might be the 10 gig interface, and this might be the 10 gig interface, and the rest of the red interfaces going from those routers are 1 gig interfaces in the red lines. So this is an example of a layer 1 diagram in a low-level design. In this diagram we have various other things to consider. Okay, so when we zoom in to this handover a little bit more, and if you look at the handoff between 10 gig 001 on the MPLS CE1 DC1 router, you notice that we have business unit 1 business unit 1 VRF, which is in VLAN 100. You then see, if you look at the handoff from that MPLS CE1 to the data center aggregation switch, then 10 gig 000 correlates to OSPF 100. So here what we're really saying is that VLAN 100 corresponds to OSPF 100, and those are both green. Then if we look at the next interface and the next VLAN and the next OSPF process, if we go from the top to the bottom, we have Gigabit Ethernet 001 on you're running OSPF process 200, and that correlates to business unit 2 VRF and VLAN 200 on the PE to CE WAN link, and so on. So this illustrates the value in color coding your diagrams. Also, if you look at the circles that are red, green, brown, purple and orange on the diagram, these illustrate layer 3 interfaces that run between the data center WAN aggregation switch and the MPLS CE. In this diagram, we look at layer 3 underlay routing design, or the layer 3 routing design, and in particular what we're really talking about is what is the routing protocol that's run between the PE to CE, that's EBGP, and then handover on the LAN in this scenario is OSPF between the CE and the core data center switches directly. And then here we actually have another router handoff between these two, and then the same happens on this side, where the routing mechanism that I've just drawn in going left to right is actually static routing. But once we get there, this is OSPF, which is illustrated by this OSPF instance and this OSPF instance. So you see that we have a mixture of OSPF on the LAN, static on the LAN, and BGP on the WAN. This diagram provides a very easy to understand overview of that when you take it at face value and zoom in. And this is the objective when we are doing low-level design, is to illustrate things like this. You can also see in the picture that we have some IP addressing, so this also almost hits two birds with one stone, which shows us a high-level routing protocol representation, but also IP addressing. So if you look at the diagram where you have MPLS CE2 and MPLS PE2, you can see the service provider to customer subnet is 10.250.21.120/31, and then we have, or it might be /30, that's a bad example. So if you look at MPLS PE1 to MPLS CE1, we have 10.250.21.124/30, and then we have .125 as the PE, and then .126 as the CE. This is easy to read and understand, so if anybody coming and looking at this network who had never seen it before, they would be able to look at it, digest it, and have a good idea of what's going on. Now we're going to move through a low-level design document and talk about the structure. So you see we have a table of contents where we first start talking about the overview and the background of the project, and then the actual customer requirements. We also talk about what's in scope and out of scope, and then move into the layer 1, 2 and 3 design. The layer 3 design, as you can see, has multiple different points to it. So we have IP addressing, overlay networks, application routing, LAN routing configuration, and so on. We then move into the QoS policy, encryption configuration and design. Before these are, it should be mentioned, I should say, that these are high level, or not high level, they are global configurations or designs that are defined for the whole network, whereas in section 5 we move into the specific design in the data center, in data center 1 and then data center 2, before then progressing through to the site designs where we have site type 1, site type 2, and so on, where we have a repeatable design. So you can see we have edge site 2. We start off with the as-built configurations. So these are the configurations after the pre-build is complete. Then we have the layer 1 physical design, the layer 2 design, the layer 3 design, and so on. And this approach is repeated for every different site type. When we've completed the site type designs, which is repeatable, give or take the type of connectivity, we then move into the management design. So things like device access, management tools, management tool 1, how we manage from the command line. Then after that in section 9, we talk about overlay or WAN migration plans. So these are the low level migration plans. Finally, we finish off with project acceptance testing and a couple of different tests that we include. So just to flick through this design document, here is the overview section where we just have a bit of a summary on what the project is about and what the scope of the project is about. This should be high level enough so that somebody can read it in one page or so and then understand what the project is about. Then we move into the scope section, customer requirements, have a look at the desired architecture before then having a look at what the deliverables are. So high level design, low level design, implementation plan, migration plan and acceptance tests, what's in scope and what's out of scope in regards to the solution, and then we move into the generic design guidelines. So these generic design guidelines should be applied across the entire solution, and we have a mixture of tables and configuration templates throughout this section on the WAN, the LAN, the CE handover, first hop routing, configuration guidelines, more configuration examples, more diagrams, and these could be applied regardless of the site type that you are talking about. So I'm going to flick through here. This is a very generic part of the document, but it's also very detailed. So when we move into the data center design, we then focus purely on the data center and how things are going to hand over in the data center. So you see some of the diagrams that we've already referenced earlier on in the low level design part of the document, and then we've got more tables, we've got routing protocol configuration, more tables, and you see this is a very repeatable design. Then we have config examples where we can highlight in a different color what the variables are, for example. So with that in mind, I'm going to skip down to the next section of the document because this is very repeatable, and we then move into data center 2. And when we move into data center 2, we then talk about like multiple transport overlays in the data center and things like that as well. So we eventually end up here at the end with moving into the site types. So when we move into the site types, you see that we have a picture of what the site type looks like, and then we have the configurations, the layer 1 design, the layer 2 design, the layer 3 design, the LAN layer 3 design, and then various other things like the crypto policy, application performance routing, and so on. And we repeat that for around about 6 site types in this particular design, 5 or 6 site types, before we finally end up at the last site type, which is dual internet plus or dual MPLS plus internet. And then we move into the management design, I should say. So we talk about in this section of the document how to configure TACACS, what management tools we use, management tool 1, management tool 2, before then moving into WAN migration plans. So this is how we're actually going to migrate the network for each of the different site types. So we see the different categories. This is what we will follow in regards to how each site will be cut over. And I'll provide an example of a cutover plan. Here is the project acceptance testing. So we have a few different things like factory acceptance testing, pre-build staging and testing. These are just dummy diagrams that we put in there, but this would explain, for example, the lab environment that we used in order to stage and perform pilot testing, and that really summarises the low level design document. So you can see down here that we have lots of sections and subsections, and it's quite a significant document, being 117 pages, but that is fairly normal in regards to writing low-level design documents. Migration plans. Migration plans are part of the network design Some people don't think they are, but I do. So that's why I've included them in the course. A key to network design is understanding the existing network to determine how we get to the new network. Now, I already had annotation on these slides, but I'll talk about them again in blue this time. So a migration methodology is a methodology that you follow, typically that never changes. So if I explain this in a high level, so if this is the old WAN and this is the new WAN, and then we've got a data center that has connection to the old and connection to the new. A methodology is, for example, if we have an existing or old and that connects to a LAN switch, okay, and then we get this new router installed on the end of a new WAN circuit. The methodology to actually migrate this, it follows a common theme. So we get the new link installed and then we get the new router installed. The next step would be to arrange a change window and then remove the old circuit and connect the new circuit. In between all that, you would be checking this routing table for routes. If they are there when you cut this link off and if they are there when you connect this link, so that you're not receiving a route to the site from that direction and a route from the site from that direction. So that's a methodology that never really changes, okay? A migration process is when you then go down to the next level and you say that exactly this is how I'm going to migrate this site because it's got a firewall on it or because it's got a load balancer on it. So that's a migration process. Detailed migration plans might be different for different sites or different site types. So when I say migration plan, I really mean migration process. We cover this further in the WAN design course. This is a slide from the WAN design course. So it's just highlighting that if you were to attend the WAN design course, or one of the other courses that focuses on migrations, then we would cover this in a lot more detail. Many principles of migrations across multiple different technologies are the same regardless. So it doesn't matter whether you're doing a LAN migration, a WAN migration, and the methodology that I always communicate to my students is pre-provision, cut over, decommission. So pre-provision, cut over, decommission, that relates to pre-provisioning is getting as much set up as you can ahead of the cut over, which is moving that LAN cable from the old to the new. And then decommission is removing the old network or configuration or whatever was in place before you actually done that cut over. We gave a migration example, a high level one. So test plans. Test plans are the responsibility of both the network designer and also the customer. So the reason for that is we have a few different types of test plans. So the sorts of things that the network designer should ensure is done as part of the project are equipment test plan, so make sure the equipment that arrives is fully functional. So this would be when you're setting it up in the lab. So it might be the network designer, or it might be the network engineer, or the TDA. Power on self-test, that's basically powering the router on, making sure that it works, rebooting it, and all this type of thing to make sure that, you know, it's not dead on arrival. So that's an acronym or a term that you might hear, dead on arrival. And it basically means that you take it out of the box and it doesn't even switch on. So then you would return it to the manufacturer and get a replacement. Protocol behaviour test plans, that might be related to ensuring that traffic is being routed a certain way over link 1 or link 2, or if you want certain types of application traffic to go over the internet and the rest to go over the private wide area network. Service acceptance testing is slightly different, where it relates to application testing. So this is where the customer probably has more responsibility for defining what applications they want to test and how they should be performing. So that's a bit more of a joint effort between the customer and the consultant or the network designer / engineer. And it's normally a separate test plan on its own, because it's quite different doing an application test plan versus a network equipment test plan.